right, so most welcome again. I'd like to welcome Damon from ARM. He's going to give us insights on IoT. So thank you, Damon. Take it away.
Thank you. Cool. Everyone hear me? Awesome. So first of all, thank you all for coming, and I know a lot of people traveled a really long way, and thank you for coming early in the morning. I know it's been a really long conference with a lot of content. So I'm going to try and keep it high level today, just give some ideas. Let me start off by just introducing, well, let me first start by thanking some key people. Thank you, so much to Shira and to Dina and the rest of the organizers. You can see them organizing on the right-hand side, and to Jan for putting together all the IoT stuff in the pub, and his dance moves were impeccable. So yeah, thank you just for making all this stuff happen. So I just want to give a quick overview of what I'll talk about. We'll start off with an intro, talk a bit about why we're here, why all of us are here, why ARM is here, why I'm here personally. And then I'll tell you a little bit about ARM and our product that we think can really help. And then just talk a little bit about what my team's been up to in Cambridge and in the US, and then some takeaways. And then I'm very happy to discuss afterwards. So, ARM. ARM is a company that designs microprocessors, and 100 billion ARM-based chips have been shipped, so they're everywhere. And the key thing for this audience is that it's a partnership. We don't build anything by ourselves. We always build things in partnership and collaboration with other people, and we are always happy to be partnering with new people. So please come and partner with us. The thing that has been most famous about ARM is that it's low-power processors. So your mobile phone almost certainly has some ARM technology in it, and it touches about 70% of the world's population. So why are we interested in data science? Well, we're interested in solving problems, and ARM is all about solving problems, and data science is a way to do this. So one of the key things I want to say is that if you want to solve problems, you need tools, and we have great tools. And data science is really a set of tools and a way of using those tools. So what are those tools? Well, we need data and sensors. We need statistics. Sometimes we need data visualization. Sometimes we need mobile apps. And sometimes, actually quite rarely, in comparison to the previous tools, do we need machine learning. So the point I wanted to make here was that you can solve real problems right now with existing technologies with the people in this room. You don't necessarily need to be using cutting-edge, sort of experimental research level work. All the tools you need to solve some real problems right now are available to you. And it's important when solving these problems to optimize for the right thing. I really like what Ralph said yesterday. It's one thing just to get a training curve to look a little bit better or to get a slightly more accurate result. But that doesn't really solve any problems. It just gets a slightly better algorithm. And, paper submissions to conferences are an important thing. Research is important. But it's most important to connect that back to the problem you're trying to solve. And what I've enjoyed so much about this conference so far is its focus on solving problems. It's really optimizing for the right thing. And, I'm really excited to see that continue. So let's talk about some big ideas. Why are IoT and data science the right tools to solve problems? So we live in an age where machine learning is becoming extremely viable as a solution to problems. And why is that? So I think it's the convergence of having a lot of compute available, lots and lots of computing power, large amounts of data from the internet mostly, and high-capacity models. Things like neural networks are models that can really learn complex behavior. And then the algorithms for training them. Backpropagation is great, and we saw this yesterday that PyTorch, you can just take those gradients in one click, and that's great. So that's great, but it's still just a tool. So what do you do with that tool? So I've put together an equation of concepts, if you like, and something that I like to call information benefit margin. What is the point of gathering this data? Why do you bother? So you want to get some gain from it. Maybe it's business, maybe it's research, maybe it's healthcare. There should be some benefit to the data you've gained. So how do you know that this is working? Well, the value of the data and what you've done with that data should exceed the cost of collecting it. That seems like a sustainable way to keep going. So I would encourage people to keep that in mind whenever you pick a problem, because there are lots of things you could tackle, and it's hard to prioritize the most important ones. So that's data science and how I think it can help. If you take machine learning and all of the really powerful things about it, and keep a sanity check of why you're actually doing it and what you're doing it for, then I think it's a really powerful combination. So what about the Internet of Things? Well, all of this data that we have in the first equation mostly comes from the Internet. This is people's behavior in the digital world. IoT, Internet of Things, gives us access to the physical world. This is now data about what's going on, potentially in real time, right now, wherever the sensors happen to be. And because these sensors are becoming cheaper, easier to deploy, and lower power, they can give us more information about a larger section of the world. So adding data from the physical world into that first equation and solving problems that have a positive value of information benefit margin, I think is a really powerful way to go forward. So that's all really abstract nonsense. Let's look at an example of an actual IoT deployment at scale. So on the left, you can see some streetlights. These are in San Diego, in California. And streetlights are kind of a boring thing. They light the streets, cool, great. But what if they could be more than that? What if they could tell you things about traffic, crowds, air quality, gunshots even? Then you could use these to improve the lives of citizens and help the city save money. So what's happened in San Diego is they've deployed 100,000 of these devices onto the streetlights, essentially turning every streetlight into a sensor. And they use this to improve citizen safety through the things that I just spoke about, and save $250,000 annually. And that's all really cool. It's great for the city, it's great for the citizens. But what about researchers and entrepreneurs? The real key thing is that this data was made available. So if you're an entrepreneur, if you're a researcher in San Diego, you can get access to this data. And you can build a startup, you can start a project, you can do healthcare research, and I think that's a really good model. So this, as I was saying before, it was not something that ARM just does by itself. This is done with GE, and they've done this deployment. So what are the key things that make this work? So if we start at the top, we've taken something, a thing, a streetlight, and basically connected it to the internet. So we're sending data from the nodes into some storage, and then models can be run on that, and then the results of those models can be looked at in a user interface in like a web app, say the traffic for the city on a given day, and then actions can be taken. Maybe a new road gets planned, maybe it's just a matter of changing some sequencing on some streetlights that can be done in real time, and sometimes you might even want to push the actions back to the node. So maybe a streetlight has gone out and needs to be replaced, or maybe you can even predict that that streetlight is going to need to be replaced, and you want to take an action at the node. So that's a great deployment, but that's one use case. So what can we learn from that use case? So the key thing is that you have ideas, you have interests, and you have expertise. And the key thing about this deployment is that it's a device, app, something running on a chip on those streetlights, and then some cloud app, some web app, some storage, and you just want to be concerned about your use case. You just want to build your livestock sensor, your plant disease sensor, whatever it is. You don't want to worry about all of the stuff in the middle, and there's a lot of stuff in the middle. Just from the IoT practical we did, we saw how difficult it can be just to maintain a stable internet connection. So there are challenges. And in order to accelerate the pace of development and the pace of innovation, those challenges need to be tackled. But preferably not by the person trying to solve the actual problems. So what are the main challenges? Well, first you need some device that can actually run the compute requirements that you have, actually run models, collect data, and you want that to be secure. If you're capturing personal information, if you're capturing information which is sensitive for some other reason, it needs to be secure. And then you need to connect somehow. These things don't really matter if you can't get the data off the device. And then you want to run the services. You want to make sure that if you have customers or if you have users, they don't get their service interrupted. And that's what ARM Embed does. It solves these problems so that you can focus on the application that you care about. So here's just a rough schematic of how it works. You have your device app. So what we saw are our moisture sensors, and you have the cloud app that consumes the data, and ARM does all the stuff in between for you. And there are different kinds of security that are important here. You want the device to be secure, the communication to be secure, and the life cycle, so sending updates, should also be secure. So here's just a more broken down version of that, of the kinds of services you might care about. I'm not going to go into that in detail. Okay, so that's ARM Embed. Most of you have played with it. I won't say too much more about it. So what are we doing right now? What's going on in the ARM data science team? So we got some data recently from Smart Cambridge, which is air quality measurements around the city. Cambridge is quite a small city. But air quality is a global problem. It turns out that 5.5 million deaths per year are due to air pollution, and it's getting worse. So I won't go too much into this. Michael knows a lot more about it than me, and he's talking later, I think. But even in Cambridge, which is quite a small city with not a lot of sort of heavy industry in it, still more than 5% of Cambridge's population mortality was attributed to air pollution. So there is data from parts of Africa, but at least in the data sets that I could find, it's pretty sparse, but it doesn't look good. It looks like it is above the median. And there are people in the room who are much more clued up on that than me. But I think that the public should have easy access to this quantitative information. And IoT systems are ready for this. There is no new technology required to make this happen. It just needs to be done. So I have a demo of what we've done with the data that we got from smart cities. And it just shows that you can do interesting things just with raw data and some visualization. So here we have, it hasn't rendered very nicely, but this is the sort of city center of Cambridge. And here are some farms. And this is the main road, and this is the hospital. And what we're showing is the output of the air quality sensors in a metric called AQHI, which is kind of a normalized version of air quality, where 10 is really bad. So 10 here is represented in red. And we tracked it, well, we got the data from Ian Lewis at Smart Cities, and we plotted it for the last year. And this is what it looks like. So you can see it changes day on day. And then if you look at what happens in November near the hospital, it starts to get really bad. At 10. So that's really bad, right? Hospitals, sick people, elderly people, and the air quality is really bad. So we can now go and investigate what's happened just at this point. And it turns out this is pretty close to where the exhausts are for the hospital, for the heating. So it may be okay, but it may also be a problem if there are other parts of the hospital nearby to this point. And this is when it's getting cold. It's winter time in Cambridge around this part of the year. So if we play it, we can then see as it starts to warm up, it's still cold, still bad, and then it starts getting better as we get into January and it warms up, and then the data ends. So this was done in about a day, just from a data set which is publicly available, and using a tool called Tableau, which is a really nice data visualization tool. I think you can get licenses for a student. For enterprises, you do have to pay for the tool. But we are finding this really useful at ARM. Which is kind of to my point. There's no machine learning in this. There's nothing fancy. There's no model. There's just visualization of data, and that already gets you some of the way. Okay, let me switch back to the slides. Oh, why is that not working? Oh, there we go. All right, cool. So here's just the maths, if you like. Some details about it. These slides will be online, so I'm not going to go through it. So that's something we've done sort of in the recent past. What are we doing right now? Well, Dina and Shira have really done an awesome job of organizing a field trip for us tomorrow. We're going to go out to a cow farm and to a chicken farm. and we'd like to invite you to join us. We have 30 spaces in the van, I guess, or the bus. And what we're going to do is we're going to monitor some cow activity, check their movement with the accelerometers, and we're also going to go to the chicken farm and look at the humidity and the heat, or the temperature within the chicken house. And here's some details around the sampling. The dates are wrong as of this morning. It's all happening tomorrow. So I do have to ask for some help, though. We don't have any devices left. So can you please come and join us? Because we need you to come and help us do it with the embed devices that we gave out. So please come talk to me afterwards to sign up so we can actually go and do this field work. If you have accelerometers, those are really, really what we need. And also batteries. If anyone has the 9-volt batteries, that would be helpful. So yeah, please come talk to me afterwards and let me know if you'll be able to bring an embed board along to do the field work tomorrow. Okay, so my final point is that this is about you guys. ARM, from our perspective, we just want to enable you to do whatever you want to do, however we can help, and we're here to listen. So please come and tell us about the things you're working on. You can always talk to me. Jan's sitting in the front. Everyone knows Jan. So please come tell us, let us know what we can do to help, and we'll try and connect you to people that can help either within ARM or within the ecosystem of ARM partners. So I think that's it. That's all I wanted to say, except for thanking you all for being so engaged and doing such great stuff at the conference. Thanks. Do we have time for questions?
Yeah, questions?
Thanks for the presentation, and thanks for the practical section also. Really appreciate your the things you are doing for us. On the slide, there's something I didn't understand, where you said, "What are we doing right now?" Can you go back to the slide, please?
This one?
No.
This one?
No.
This one?
Yeah. Bullet point 4. African data is sparse, but available data revealed PM levels. What are PM levels?
Right, so PM is particulate matter. So this is stuff that's like particles that are in the air. And the only data that I could find, admittedly after a fairly quick search, just said that from what the data that had been collected, looked like it was above the median. So it was towards the high side compared to the rest of the data set. But I'd refer you to John and to Michael to talk more about the data sets here.
Okay. Yeah, thank you, Damon. About the practical session, is Dina going to give us the details where people are going to meet or what time you're heading off for that?
It's a good question. Dina, what time are we going to head off tomorrow?
The plan is to leave campus at 9 a.m., but I need to know how many are coming off campus. I mean, who are staying out of campus so that we can try to arrange to cover your transport to campus. So we really need you to sign up with Damon so that we can finalize the plan. But the time we'll leave here at 9 a.m. and I think the session will go on till 2 p.m. Thank you.
Thanks a lot, Damon, for all the support and the sessions. I had a quick question about the deployment in San Diego with the street lights. I wonder, did the city find that it was worth it, the deployment? Because you put some dollar figure there. Was it worth? I mean, I guess that's a saving, but in general, what do they think of actually these investments in IoT?
So I don't have a direct answer. I haven't spoken to the mayor of San Diego, but this deployment went out, I think, in 2014, and it's been running successfully for 3 years, so they've been renewing it. And the business model from the ARM partnership side is a per device per month kind of a thing. So I guess that means that they're happy to keep paying that and keep doing it over the last 3 years. So I think it's a positive sign. I think what's more interesting is the ecosystem that it's enabled. There are a few other startups that use that data to
If you could go down, one of the slides down.
is it that one?
No? Next down.
That one?
No.
Tell me when I hit it.
One of the slides down towards the end.
This one?
Yeah.
Right. Oh, okay, yeah. So the point I just wanted to make here was that in a city like Cambridge, the city is a couple of 100 years old. It's very hard to change some of the infrastructure. But in a city which is growing quickly, where you're building new parts of the city, you're free to design smart things into the city from the beginning. You don't have the cost of replacing an older system. You don't have to deal with legacy systems. So one of the really hard parts of data science that I found from working within a company is you build some shiny new thing, and it's awesome, but now you have to plug it into some 20-year-old system. And the way things were done 20 years ago is very different, the languages are different, the interfaces are different, and that can really slow things down. So here, I think things can be done very quickly if you're, say, going to build a new road. You don't have to replace the old sensors or streetlights. So I guess my call to action there is that if you think about what kind of data you would like to collect and what questions you'd like to answer before you take an action, like building a road or expanding a city, you can build these things into it and really benefit from it very quickly. Does that answer your question?
All right. So we'll take 2 more questions, then.
Thank you. I just want you to have some slide, let's move to this.
Forwards or back?
Yes, there. When you're connecting to the cloud in terms of security, are you supposed to start with the security and then the hardware and the involvement, or security has to be in the middle of the two? Which is the two is supposed to be first in terms of security of your application?
So is the question, where do you start with the security?
In terms of if you to deploy an IoT system, do you start with
We see lots of news about various websites getting hacked, various online sort of services being hacked, and those things are damaging, but they're not, someone, destroying some part of a city's infrastructure. That would be a really, really bad outcome. So, yeah, it's absolutely essential to go completely end-to-end. Yeah, maybe it's not a satisfying answer. The answer is it has to be everything.
All right, any other questions? If not, let's give them another hand clap.